Quick introductions, guys.
Sure.
Very quick. Okay, we keep it pithy.
Yeah, let's keep it very short. So I'm Oleg. I'm head of solution architecture. I'm with Star. I've been with Star for more than 12 years. I'm now responsible for our development of our automotive mobility group. And my focus spans across multiple kind of directions, starting from the business development and sales and all the way to R&D activities and project delivery. I live in Kiev, Ukraine, and have background in engineering and quality assurance. Over to you, Manuel.
Hi guys, my name is Manuel. Title is Head of Design. I'm based in Munich. I work here with a multidisciplinary group of designers, and we have a focus on automotive and mobility. Over to you, Pavel.
Thank you, Manuel. Hi everyone, my name is Pavel, and I'm from CloudMade. I'm working in a position of Head of Data Science and Engineering, and my background is connecting mostly with mathematics and research. Over to you, Jim.
Hi, yeah, I'm Jim Brown. I'm Chief Technology Officer of CloudMade, and means I'm responsible for engineering and all of the technical aspects of the company, as well as working with a lot of our key clients and OEMs. So, move on.
All right, perfect. So I guess, first of all, thanks a lot for joining, you guys, and for being patient. Hopefully you can hear us now. So we'll probably shrink this agenda a little bit just for the sake of time. So quick intro about the Star and CloudMade and what we do in the automotive mobility space and why we are presenting today. Then we'll quickly describe what is the product we're building in order for you to get a better context when we switch to discussing the process and the building blocks behind it, which is going to be the main section of our webinar today. And then we'll hopefully still have some time for the questions, but you can use questions panel in your tool, in your meeting tool, in order to ask questions as we speak, and we'll try to actually answer all of them in the end. So very, very brief company's introduction. So Star is a global consultancy company. So we help our client bring their digital products and services to life through combining strategy, design, and engineering in a very, very efficient manner. So in a nutshell, you would actually, clients would work with us starting from the very first day they have an idea, a great idea that has to be put to life, and all the way to the day when we launch it into production and beyond. So our focus is actually on three main areas. It's automotive mobility, which is 40% of what we do. But also we do work in different domains, mostly in health and wellness, and also in industry manufacturing and fintech. Star has been around since 2008, and since then grown to 750 people globally. Over to you, Jim, for quick CloudMade intro.
Okay, so CloudMade is a product company, and the product that we produce and we sell to OEMs is a set of frameworks that can enable smart adaptive features in vehicle, cloud, and car. On top of those frameworks, we also supply learning modules, and the learning modules are things that can understand different aspects of human behavior and build profiles to enable predictions. Critically, the framework is also open, such that an OEM can bring its own machine learning intelligence to the party and very quickly and easily install that into the framework, and so not have to replicate all of the plumbing and profile management and authentication and identification of users, etc., across various solutions that run on top of the framework. Because in the end, it is the solutions that the OEM is buying. So the OEM is intending to do things with the product, and we work with them to deploy those solutions. To the next slide. We are globally distributed. We work with the OEMs at their locations as well as at our central development facilities. And we work globally with OEMs across the world. If you go to the next slide, there's a snapshot of some of the OEMs and automotive manufacturers and tier ones that we work with. Critically, we tend to work directly with the tier ones and tier twos and the OEMs. we don't have a multitude of other business models. So we focus on the OEMs and people who are working in the ecosystem of the OEMs. And go forward one more slide. And again, the things that we offer are technology products, frameworks that can run at the OEM site, so they don't have to just give us their data, that provide innovation and digital transformation around and leveraging the connected vehicle software and into consumer apps and services. So it's a variety of activities, but it's always targeted at how do we help the OEM build better products for their customers. Go on.
All right, perfect. And let's jump right into our topic then. So first of all, let's talk about the end game. Like, what are we actually trying to build in the end? I think it's going to be very important to understand it as we talk through the process and the building blocks in order to have some context of what the driving coach means for us. So the first questions we always ask our clients is, what is the problem we're trying to solve? Why are we actually creating this product or service? Who's going to be using it and why? So if we ask the drivers, probably they would say there's no problem. Most people believe they're very, very good drivers, and they would never tell you the story how they failed to be a good driver on the roads. They usually tell you the story where it's another person who failed and caused an accident, or it's a vehicle that actually is a piece of junk, or it's a road infrastructure that wasn't straight or good enough, and that's why the accident occurred. So as the people drive more and more, they actually becoming more and more confident, and it's very hard for them to admit that actually they're driving in a bad way. And sometimes it's just the style that actually lasts for years. But luckily, we do have the data, and data shows that human error is contributing factor for a big percentage of the accidents. So it doesn't mean it's the only factor in every single accident. That's why the numbers don't add up to 100% here, but it's one of the factors that actually present in 93% of the accidents, which again make us think that maybe people are not right. So maybe they're not very good drivers, and with all the technology that's actually OEMs are currently deploying to help them, they still make mistakes, and it still causes maybe, if not 93%, but a big percentage of the accidents. Moreover, we know that most accidents actually happen on a very familiar routes. So it's not because the person is stressed out, or person is unfamiliar with the environment, or person is unfamiliar with the traffic signs or the vehicle. It happens on the same route that actually you take to go to your work office, or back to your home or to an apartment. So it's got to be something that's not related to the external factors, but something that actually has to do with how you actually drive, right? So our product would be a product on a very important mission to help drivers maintain a smooth driving style. And which is seems to be a very basic task, but it's not, because as people get used to driving a certain way, as people actually acquire their habits, it's very, very hard to change them. It's especially if it's actually the habit that's been around for years. It's not just hard to make them do stuff differently, it also very hard to find incentives for them to actually do stuff differently. They actually have to want them themselves, and in this specific case, it's very tricky, right? So what seems to be a pretty straightforward thing to do results in a very actually complex problem just from the user standpoint. So who are we solving for? Of course, the primary use cases, when you think of a driving coach, you probably say, okay, we're building it for the novice drivers. So people who are just starting to drive and they don't know how. So there is no need for them to actually change behavior. And you'd be correct. So it's of course, a primary target audience, but there are definitely more, right? So they're not the only ones. So if you think more about it, there could be multiple user groups and multiple driver groups that actually then could be doing a very bad job while driving. So if you think about the occasional drivers, people who only drive the cars when they are on vacation in another country, or people who only drive a car when they have to go on a business trip and it's a corporate car. So they drive maybe a couple of times per year. Are they good drivers? Probably they could use some help. The stress drivers, so the people who actually rush home from work and they're stuck in the traffic jam, or they're actually trying to wrap up their work while they're driving because they are stuck in the traffic jam. I personally did it myself a couple of times, so guilty there. But basically, again, this actually causes them to be focused on something else while they're driving, and results in a pretty bad driving behavior on the roads, and they're not actually focusing on what's happening around them. Right? There's also a category which is, I guess, the hardest to tackle, which is reckless drivers, people who just think the way they drive is fun, and they could be doing that for, I don't know, 20 years, 30 years, and those would be the hardest one to change. Probably there is no silver bullet for them. There is no, and the incentive got to be very, very good. We also have a new category emerging, which is the aware drivers. So people who actually want to save environment, or like to reduce their carbon footprint, or for example, to extend their electric vehicle range, right? This can also be affected by the way you drive. So there are lots of user categories, and each of them would have their own incentive to actually, and their own approach to driving, and we need to consider them all, not just the beginners. So what exactly are we building? So we're building a pretty complex, actually, piece of product. It's probably going to be very tricky to understand where those requirements came from, but we'll actually get to that as we go through the process and the building blocks. For now, I've just given you this for the context to give you a better understanding what exactly we're going to be building. So we're going to be building a product that's going to live inside of the infotainment system for the most of the time. So it's going to be actually working as you drive. So it's going to be interactive, and the primary actually use case for it would be actually to help you drive smoother and faster. It could also live on mobile for you to check your stats or check your progress afterwards when you're home, but it's more of a secondary thing in our case. It has to be personalized, so it has to be a software that's intelligent. We're not building a driving coach that is just a collection of the videos, or collection of predefined tutorials on how to drive, right? So it has to be something that's tailored for you, and it has to actually give hints that are also applicable to you specifically. We want to build something that's gamified and has positive reinforcement, so people are actually interested in using it, but also they get something as they actually progress, right? We wanted to make it very personalized, so it actually also becomes not just reactive but proactive, meaning that before you get to the roundabout, before you get to the crossroads, it's gonna give you a hint if it knows that actually have problems crossing, for example. Right? So it has to predict things beforehand. It should give you an indicator on how you drive in real time, and also show you your progress. So are you becoming a better driver? So it should answer the question for you as you progress. It also has to be very forgiving and friendly. So it has to be like your buddy giving you friendly advice versus like your strict mother judging your decisions, right? Or telling you how to do things. So quite a lot of requirements that will have to be fulfilled, which actually results in quite a few significant challenges that actually we're going to discuss in a second. So what are the applications? Of course, the primary one is safety. So safety, we already talked about that. Driving smoother means less accidents in the end of the day. So of course, users are going to be interested in that. Most of the users are, and safety is always on top of the list of what users are concerned about. But there also could be others, right? So for example, it could be a feature introduction kind of aspect where the driving coach would teach people to use specific vehicle functions like adaptive cruise control or the driving modes. A lot of people don't know how to use them and what they're for. So driving coach could actually suggest the situations where those are applicable, or teach them how to use their parking sensors and make the driving more efficient in the sense. Efficiency is also a very interesting case. So a lot of people are interested in actually prolongation of the driving range for the electric vehicles nowadays. So range anxiety is still out there. So the way you drive can actually impact that. So there also could be an incentive for some of them. Same for the fuel vehicles. It's reducing fuel consumption is also directly related to how people drive. So for some of the user categories, that might be also an interesting use case. And at the end of the day, maintenance is also actually pretty costly. So some of people could be interested in actually reducing the maintenance costs for the tires or the brakes, and they actually, that could be an incentive for them to drive smoother and change their driving behavior. So now that we know what we're building, let's discuss how to do it. So we're going to discuss the process and the building blocks, but let's start with the complexities. So there are a lot of complexities, but from design engineering standpoint that we have to take into account before we actually start building this. So I'll turn it over to Manuel.
Yeah, thanks, Oleg. So thanks for explaining the context and also talking about the requirements. There are many challenges when it comes to designing a system like that, and we always set ourselves boundary conditions when it comes to starting with challenges like this. The challenges are multifold. The first one is the engagement over time. So we want to build a personalized product. The next one is it's a highly regulated environment that we are designing for. There might also be a very high cognitive load when it comes to the driver. Hence, we only want to surface feedback or suggestions which are, first of all, safe at this point in time, but also have a positive connotation. The third aspect to consider when it comes to designing for this topic is that the system to be intuitive, universally understood, regardless of the experience of the driver, but also initially, and also regardless of where it's applied when it comes to localization. So we want to build on existing mental models. And the last point that we've listed here is, again, the time axis, the learning journey. We want to gradually onboard drivers and also, again, offer a personalized system. We need a high degree of engagement. We need people to stay with us in order to surface the right recommendations at the right time. Thank you.
So regarding the engineering aspects of the complexity, the problem at hand involves learning about individual users, but also learning across users what kind of patterns and interactions work and what the real world information is comprised of it's being brought in by the sensors. At the same time, the experience of the user is in the dashboard, but could also be in the mobile phone and could be in multiple cars. So this calls out for a hub and spoke model where you basically have data coming together in the cloud, but also being distributed to multiple devices. So where it comes together, it supports cooperative learning and validation, and where it touches the user in various devices, it supports interaction and prediction. What's critical about this is that because of the safety factors involved, you don't want to be relying on an online system. So one of the major engineering complexities presented by the problem that had to be addressed in the solution and the enabling technology for the solutions was this hub and spoke model, arm's length relationship, and synchronizations. That and the fact that you had to have a continuous learning model and a robust offline mode. So those were the number of the key engineering complexities. Go forward to the next slide. So to support these complexities and to support the use case and the features required, there were 5 key areas that had to be addressed as independent building blocks that work together. The one is the platform for the collection, transferring, and enabling different kinds of training and work models. The second is the actual machine learning that involved understanding both the personal and the cohort, the persona-based behavior. the integration with multiple data sources, both in the vehicle and from the cloud, for what the context was, the real world context, the weather, the traffic, etc. And then the technologies that allow the gamification of the solution. So there's a technical framework that's required to make the solution engaging and to enable the use cases envisioned by the designers. And then on top of all of that, none of this is of any particular value unless you can validate that you're actually achieving the core goals of helping people be better, smoother, safer, more enjoyable drivers. So there's a whole validation set of points. Those are the building blocks that had to be assembled.
All right, so now we'll start to go through the kind of process, starting from the very first phase, which is called research. So I'm going to turn it over to Manuel to talk about research and design before we jump into the engineering topics.
Yes, we are going to quickly cover research design and then also the architecture and the validation. But first we start with, actually looking at the competitive market. We also are very diligent when it comes to our user research. We have a multitude of methods on that front. To actually build personas. We build personas always based on validated data. We've talked at the beginning of this webinar a little bit about the different user types that we would like to address. So we take that very seriously, and we then consolidate all of that in user journeys. You see a snapshot of a user journey here at the bottom right, where we look at the different stages that the user will be going through, all the way from getting introduced to the product, onboarding, to driving, but also to getting recommendations later on. The design phase builds upon all of this knowledge that we aggregate in this stage. And we can move on to the design stage, where first we also make sure that we acknowledge the brand that we are designing for when it comes to all the brand assets and the corporate identity. But on the other hand, the cockpit is a complex environment to design for when it comes to the multi-screen environment that we are having. Plus, we also in this case want to be present with our solutions on the user's mobile phone, which has a huge advantage when it comes to the learning engines. So we start with understanding all of that and also making sure that we are orchestrating the information at the right time and also at the right space with the real estate space that we have on these respective screens. All the time acknowledging the brand that we're designing for. Next, we start to detail the use cases. Detail might be a word that's too strong at this point in time, because we start with small pieces of paper and thick pens, which basically allows us to not get lost in falling in love with an idea or a solution too early. It really focuses us on the essence of what we are trying to do at this point in time. We are already starting to flesh out entire systems at this stage. Wireframes are built, and at the beginning we always also go back to testing our wireframes when it comes to the scale and also the brand fit. So that's happening all at this stage. I want to highlight two things on the next slide. The first one would be that we are big fans of an iterative design process. We don't think there's any other way of creating a solution that eventually solves the problem, exceeds expectations of the users, but also has a high rate of adoption. So we design, build, test, and learn continuously throughout the process. The vehicle is a tough environment to test, because there's many safety regulations that you have to consider, but we have found many different ways of doing that and simulating the environments that we need to test our assumptions and the hypotheses in. And we do that continuously. That's covered on the next page. We don't only do that with our team. We conduct user testing at all stages of the design process. run through multiple programs in my history, and I can assure you, and many of you guys are also familiar with that, it's phenomenal what you discover, and the wealth of knowledge and also the improvements for your products that you get out of user testing is just fantastic. So we're big fans of an iterative design process and also of user testing. That's the first two parts, research and design, and we have two more before we come to the Q&A section, architect and validation.
Yeah, Pavel, over to you.
Thank you, Alex. So the architecture. So how did we attack the problem from the technical and engineering standpoint? So first, we developed and used the hybrid version of a framework to collect the data and to proceed all the necessary information. So the idea of this hybrid architecture is that first part that is deployed inside the car is giving us the possibility to collect all necessary data and sync this data with the cloud. So the cloud part is responsible for data storing, data aggregation, and running all the learning models. So all heavy calculations are made in the cloud, and the result is what we call the driver profile, is sending back to the vehicle. This driving profile includes some information about the driver, plus different machine learning models that were learned and trained in the cloud. Then the prediction could be made independently from the cloud directly in the vehicle. There are several advantages, big advantages of this architecture. First is that because all the calculations are made in the cloud, we do not care about the computational power of the embedded solutions that are existing in the car. Secondly, because the data is storing in the cloud, we are able not only to use the personal data from a single driver, but we can enrich this data with other information that we can collect, including this weather, calendar, information from social networks if needed, etc. And we are also able to aggregate the information between different drivers. They give us the possibility to run to use different techniques, learning techniques that typically called fleet learning or cohort learnings. So we can understand the behavior of group of drivers under different circumstances. The third big advantage of this type of architecture is that prediction could be made even in offline mode. So we need connection periodically just to synchronize the data and periodically download the updated models on updated information from driver. But because prediction are made independently in the vehicle, they don't require constant cloud connection. Can we go to the next slide? Thank you. So the next part of the architecture is the set of machine learning models that we developed specifically to solve these problems that were described. And these machine learning models are enablers that can provide all necessary information to make a correct decision in the future. There are several types of models that we use. Some of them are connected specifically with the detection of the situation. It's cognitive load detection, danger spot detection. So this type of information is needed to understand what is going on right now. The second type of information is about the prediction. So we want to understand what will happen in the future. In this particular case, we use several models that are predictive destination, predictive routes, and predictive driver behavior. So the idea is that we want to understand what happened in the next 5 minutes, 10 minutes of driving, etc. The third type of smart models that we use there are mostly connected with the notification and with information that we are displaying to driver. So it's smart notification logic, reinforcement learning. So it's the system that constantly learns how user react on the information that he or she observed in the vehicle, and the system adapts to this reaction to make them less annoying, less distracting, and more useful for each specific user. Can we go next? We obviously had, before we will integrate all those models into the vehicle, we first of all need to validate and to check that all those models are working correctly, and we use a variety of different methods and tools to do this. Some of the models could provide some interpretable results that are also used to our product and design team to develop the right type of interface and to understand what are the most influencing contributors into the results. Also, as a part of the framework, we have a module called validation framework that is able to validate the solution of each individual model for each user or for group of users, not only on the research stage, but also in a production stage. We have continuous validation of all the modules that are working for the whole fleet. Can we go to the next one? Yeah, so at the end, the next step, so it was an innovation project, but the step for development and deployment this project into production, it will have different options, deployment options. Despite the fact that we chose the hybrid version of the architecture, it could be a relatively easy move to either onboard learning type of architecture when everything is deployed in the vehicle, or fully cloud architecture. So all these three types of architecture have their advantages and disadvantages. For example, when we are talking on onboard learning, obviously it will require a lot of computational power, or some computational power, some more computational power in the vehicle, and we will have no access to the fleet data. On the other hand, we do not require to have all cloud infrastructure for that, and we are not worrying about data transferring, data privacy, etc., because all data is stored in the vehicle. The opposite way of deploying could be cloud-only solution, when everything, including predictions, including all the logic, was implemented in the cloud, and you just put in some request to the cloud to get the feedback. The advantage of this approach that yes, you are not linked to the and you're not dependent from the embedded solution or the embedded model in the vehicle, but you need to have a constant internet connection. You need to you will probably need to increase the amount of data that should be stored or should be sent to the cloud and then received from the cloud. So the next step is how we are validating the whole solution, not the only separate model, and I would ask Jim to cover this section.
Yeah, let me make a few comments on this. So basically, in the end, the recipient of this technology, of this solution, cares about three types of things. The first is, does it actually work? Is it accurate? And that's because of the metrics that Pavel talked about, including our selected destinations correct? Do we predict user behavior correctly, etc.? These are observable predictions that can be measured and monitored. And so that's one way that it's verified whether or not it achieves its stated goals. The second two items on this list are actually even more important, because a main goal of the solution is that users like it, use it, and engage with it. So as measures of user engagement, it is how well are users progressing with challenges, and are they collecting rewards? So are the users attached to the thing that the product is doing for them Is it entertaining to them? Is it engaging? Does it capture and captivate them? But the highest underlying requirement of it is that we produce safer drivers who enjoy driving more and drive better. And so the final metric is that we can look at the behavior and the outcome of the users who have been engaged and see whether or not the index of dangerous events and unsafe activities has gone down, which was the overall intent. So what's critically important here is that while we're building these systems and we have all kinds of measurements, technologies, pieces that we deploy, etc., in the end, what really matters is, does it achieve the basic business goals set out by the customer, which are represented in these types of metrics? And I think that brings us towards the end of our content. Oleg, did you want to take over for a minute and then do some Q&A? We actually hit our time mark even with the communications muck-up. I'm impressed with us. So we have a little time for QA, I think. So.
Yeah, I think we're in the end of the hour, but can take a few questions if there are any. So thanks everyone for joining and actually looking through the presentation twice, but just without the sound for the first time. So we apologize for that. Hopefully you can still find it useful. So we'll try to answer a few questions, just being mindful of everybody's time, and this might be an in Europe as well. So I'll try to, here's the first question. So the question is, how is it different from the Volkswagen Think Blue trainer that I have in my car right now? I'm not sure, guys, are you guys familiar with that? Any of you?
So unfortunately, no, I'm not familiar with the Volkswagen. What was it called? In Blue or Blue?
It's called Volkswagen Think Blue trainer.
Think Blue. No, I'm not familiar with that. It sounds interesting, and we will look at it, but it'd be hard for us to comment on the differences.
Mm-hmm. Okay, yeah, there's a link there, so we can actually probably take a look at what is the difference. Who is the intended customers? Are these OEMs, or are there any other customer profiles?
I can address that to a degree. So one of the things that's important here is that there really are two customers for this solution. The one customer is the actual consumer who uses the product, and that's who we have to address. But the person who's normally buying the technology and buying the solution is in fact the OEM, who then embeds it in their offering to those consumers. So and this is true for us in many of our engagements, is that there really are two customers. There's an actual consumer we need to satisfy, and there's an OEM that we are doing it with. And their goals are congruent, but not completely overlapped. So for example, one of the goals of the OEM is that in general, driver safety goes up and driver satisfaction goes up. The individual driver cares that their driving behavior improves. We can and will also engage with mobility providers and app providers at bringing these technologies to bear, but they normally be surfaced in a slightly different way in those environments. So this project and this model actually was deployed with an OEM in mind, but it could be deployed with a OEM, with a mobility provider of some kind. You guys have other things to add to that, Manuel or Pavel or Oleg?
I guess just my other idea is like insurance companies might also be interested in this kind of product, right? Because usage-based insurance is very, very popular right now. It's becoming more and more popular. So they are also looking into the ways to measure the way, like the quality of your driving, and maybe teaching you to be a better one.
Yep.
All right. So next one probably will go to Manuel. So what types of rewards are you anticipating? What would be the incentives for the user?
Yeah, good question. So we looked a lot at gamification aspects when it came to designing this product, and don't know if the person who asked the question is an avid gamer or not, but what's important is to consider the timeline, and usually it evolves quite easily at the beginning, and then they get a bit harder to receive later on in the process. So in this case, we also made sure that there are some awards that you get by very simple tasks and engagements, by just using our application, for instance. A second point that I would like to point out here is the power of leaderboards. People really like to compare themselves to others, and we are competitive creatures by nature. So having leaderboards was also something we considered very early on, actually, and that was also a huge success when it came to engagement and adoption.
Yeah.
That's where I would leave my answer. I don't know if Pavel or Tim or Oleg, if you want to chip in.
I think you nailed it. I would agree. Those are the rewards and the kind of human motivations that we are working with and in trying to satisfy. So, yeah.
All right, thanks, guys. So next one is pretty interesting one, actually. So do you think there's a difference between a private driver and a truck driver in terms of coaching and the solution that you actually provide to them?
So, okay, Jim, go ahead.
Well, I was going to say, yeah, it's interesting. There's a lot of studies that lack of sleep emulates in the physical body similar characteristics as being drunk. And so there are a lot of similarities physiologically between tiredness and drinking. But I think in terms of interaction, there's some significant differences. And in terms of the kind of interventions that will work, there are significant differences between tiredness and drinking. And Manuel, you might want to comment on those. But I think physiologically, they're actually very, very similar states.
I think the question was private drivers, like a person versus a truck driver, like a heavy duty truck driver, right?
Yeah. So yes, the short answer is yes. There's a huge difference between these two target groups, and our initial focus also during this presentation and also in past projects was not on truck drivers. I think it's fair to say that. Having said that, I think it would be very easy to adopt our logic also to a professional environment. Let it be truck drivers or taxi driver or chauffeur systems.
Yeah, I think so. The idea of the systems that we developed is that it adapts. The main part of personalization is that it adapts to the way of how each individual is driving and trying to fix or trying to help to fix the biggest issue for this specific driver. I think that for truck drivers, the issues that they have and the problems that they have during the drive are probably different from the people who are driving just regular passenger cars. So truck drivers probably mostly driving on a highway outside the cities. On the other hand, they have more issues with maneuvering than the passenger car. But the idea of the system in general is that it's generalized and could be adapted to any type of user, with, of course, some changes in UI and gamification that will be mostly focused on that specific user. But the whole system of detecting the issues and getting the information how this issue could be solved, the core part of the system will be very similar.
Yeah, thank you, Pavel. And there's one more that came in while you were answering, which is your system in the car integrated or a separate application?
The idea in this specific project, the system was integrated into the vehicle. We are developing different options how the system could be as a separate application, but it will have very different type of interface. If you're talking about several applications, for example, in mobile device, there are several options how it could be used during the drive. Mostly the only option is use some I don't know, Apple CarPlay or Android Auto or some other integrated system, but you're not allowed to use a mobile device during the drive. So in this situation, the system will be mostly focusing on the experience before the drive and after the drive, and we have a set of use cases like that. In this specific project, the system was integrated into the head unit of the vehicle and using the instrumental cluster of the vehicle. So the advantage of this system was that we were able to train user specifically during the drive. And we are also considering the combination of that when you have some information or notification before the drive and after the drive, and you have some constant training during the drive.
All right, and I think I see one more. Yeah, so the question is, how do you pilot such solutions in the development stage with end user vehicles? What are the challenges in piloting those?
That's a very good question. There's a lot of challenges, to be honest, when we are talking about the real fleet. So first of all, before the solution will go to the real fleet, it should be fully tested, and we should spend a lot of time on testing a different group of people, not only on a virtual environment, but on real life in different circumstances, different countries, for example, because you have different flows there. Secondly, because we are using the framework as a whole platform, it gives us the possibility to review how the system performs on a daily basis, so in a real life. And it's not only the performance of separate models, but it's also the performance of the whole system. So we need to understand how often user accepted our suggestion, how often user rejected something or disabled the system if needed. What is the similarity between users that rejected the system for different reasons, and how we can adapt the system to it and update the system. So it's give the possibility also, because we use this hybrid version of the platform, of the architecture, we are able to upgrade and update the logic on server side, and the user will be able to get updated model that will fit them better.
Got it, Pavel. Okay, and there's one more, but I think it might not be very relevant. So is this solution approved by any insurance regulatory agency in EU? So I think I can take this one. So this might be relevant because Star is a consultancy company, so we provide services, and while CloudMade is a company who provides technology. So yes, we build this solution as a project for one of the OEMs, but we're not those who sell this like solution out of the box, right? So we're not selling any products, we're selling the technology plus the services on top, right? And this one is very interesting as well. Actually, I thought about it when we actually were getting ready for webinar. So this seems to be more aligned with the average vehicle, like an average consumer vehicle. Have you given thought on how it would play in a sports car?
Absolutely. Absolutely. And we've had conversations with a number of OEMs who provide these high performance vehicles. So while driver coaching is, and the use cases we've talked about here are very much about the average vehicle, the commuter, etc., someone who buys a high-end sports car is normally interested in driving safely, but more to the edge of the capabilities of themselves and the vehicle. So a solution like this, tweaked with different parameters, can actually coax the person into where they have room to maybe extend the performance of their vehicle, to be maybe a little more hints on how to get more enjoyment and pleasure out of driving their vehicles, all without exceeding the safety limits. So the solution, while it was absolutely worked on in this case with a mass market, is what I would call it, provider of vehicles, it is extremely applicable to the high performance vehicle market. Absolutely.
I think it also answers the next one, which is, do you think a Ferrari customer would want it? Yes, but definitely in a different form, right? So the technology behind it is, of course, going to work still, but with actually, of course, the customer-facing product would be different than that.
The goals of how they drive are different, but the end goal of being safe is the same. And so what you do is you tweak how you let them operate inside that envelope. Yeah, absolutely right.
All right, and there are 4 more questions. What's the accuracy rate of the predictions? I guess it's a pretty generic one, given that there's like lots of predictions going. Maybe Pavel, you can try.
It's very dependent from the model. So when we are talking about the predictive routes and destinations, of course, first of all, it's dependent also from the user. If you're a taxi driver, predict your destination will be much more sophisticated than if you are just a regular driver and you have regular commutes. But the average, average destination rate was approximately from 80 to 90%. Routes, again, it has approximately the same amount, the same number. When we are talking about the danger spots detection, it has a little bit different type of validation, because if you know that this particular situation is like more dangerous than the another one, it doesn't mean that it's always danger for you. For example, if you're driving from side road to a main road with a high traffic, you usually have a harsh brakes or some other activities that are not regular for you, but it doesn't mean that you're doing this each time when you are doing these maneuvers. So we developed some specific type of metrics to understand how those specific model performs.
All right. So the next one is more about how the driving good coach will work in general. So besides rewards, are we only showing text messages with the devices, or is there something else to the user journey as they drive? I guess people want to know what exactly they would see when the person gets a coaching advice.
Yeah, maybe I can have a head start there. So what we actually show is, or what we set out to show, is a very friendly interface. Walks a fine line between, being taken as legit, but also as friendly and also not too serious at the same time. So what we came up with is also indication of why you're getting a recommendation. Was it hard braking or hard cornering? We developed visual cues to actually also show that. We also had an avatar present that was, in there with you and was boosting your confidence and was hopefully contributing to the engagement. And then I think the question already mentioned that we had awards of different types, all the way to very elaborate trophies. Yeah.
All right, and maybe one more for you, Manuel, but I'm not sure if you know this one. So what is the percentage of acceptance of cognitive load while getting the live feedback?
So I don't know the number. So what I was referring to earlier is that, with these systems, you have to manage the intervention. You cannot have, a harsh warning sound for a specific situation. You have to fade in, actually not have an intervention, but have a recommendation, and you also have to an explanation later. But I don't have the exact number.
All right, and maybe the last one. So asking whether the hybrid model we're using can be used on mobile phones, and if so, how will it be deployed to mobile?
Yeah. So this hybrid model, when I talk that this part that was implemented or deployed into the vehicle, in general, could be deployed into any device. So the idea of this part that it do not require a lot of computational power first, and to be honest, it's almost agnostic to different operation systems. So it could be deployed into a different mobile device. It could be deployed into TCU unit. We deployed it into vehicle telematic computers, or we can deploy it into the head unit, as in this particular example.
All right, I think that wraps up our Q&A session. So I'm happy we actually had a little bit more time for that. So I guess last kind of comment before we wrap up. So if you guys want to connect and just to exchange some thoughts or just to give us comments or just to talk or just follow us, please contact us at automotive-global or at sales@cloudmade.com. We're also can also easily find us on LinkedIn, right? And we can get connected and continue conversations if interesting. So with that, thanks a lot for joining today. And despite some technical difficulties, we actually managed to have a pretty good webinar and actually completed almost on time. So everybody have a great day, or if you're in US, or even if you're in Europe. And thanks again for joining.
Thank you.
Thanks, folks.
Goodbye.
Bye-bye.